Hello everyone, welcome to Math with Allison. Today we're going to be talking about what does 1 over x do at limit values of 0 and infinity. If you want to look at my previous videos, I have that right here. I have some things about one-sided limits and lots of others, so make sure to check them out. So we're just going to go ahead and dive into it. So what does 1 over x do at 0 and infinity? First, we're going to look at what it does at infinity. So we have the limit as x approaches infinity of 1 over x, and the limit as x approaches negative infinity of 1 over x. First, we're going to go ahead and use the table method. So I'm going to just plug in values and see what they equal. If I plug in 1, I get 1 over 1, which is just equal to 1. Plug in 10, I get 1 over 10, which is equal to 0.1. I'm writing it as a decimal so I can see what it looks like really. I get 1 over 100, which is equal to 0.01. And then 1 over 1,000 is equal to 0.001. If I were to take an educated guess, I'm assuming this is going to 0 because it's getting pretty tiny. So let's go ahead and look at the limit as x approaches negative infinity as well. And again, we're going to use the table method. Again, if I were to take an educated guess, I assume this is going to 0. I got a graph for us, so let's go ahead and check it out. So as we approach negative infinity, it looks like I'm getting really close to 0. If I were to zoom out way on that graph and keep going out, I'd be getting closer and closer to 0. As x goes to positive infinity, our function is getting really close to 0 as well. So using this knowledge, both the graph and the table, I'm just going to go ahead and take a good educated guess that the limit as x goes to infinity of 1 over x is equal to 0, along with the limit as x goes to negative infinity of 1 over x goes to 0. This is a really great application when we dive more into limits, but I have a couple applications right here. So first off, we have right here, we have the limit as x goes to infinity of 1 over x plus 3. When x goes to infinity, it's getting really big. It doesn't matter if we're adding 3 or not. It's not going to make much of a difference when we're at a huge number. So this is very similar, and I'm going to write squiggly lines to the limit as x approaches infinity of 1 over x, which is equal to 0. So I would say this whole limit is just equal to 0. Same thing applies for negative infinity. This is, I'm going to do squiggles again, very similar to the limit as x approaches negative infinity of 1 over x. That number on top doesn't make a difference because we're still dividing by a huge number. And subtracting 4 from infinity, infinity minus 4 is still infinity. Negative infinity minus 4 is still negative infinity. So that's why it doesn't really make much of a difference. So that's how we're able to manipulate these kind of functions. So now let's go ahead and take a look at the limit as x approaches 0. I have approaching 0 from the left side, and I have approaching 0 from the right side. First, I'm going to go ahead and review something that will help us in the table. So just like last time, we had 1 over 10 is equal to 0.1. If I were to multiply both sides by 10, so I'm going to multiply this by 10 and multiply this by 10, these divide out, so I get 1 is equal to 0.1 times 10. Now I'm going to divide both sides by 0.1. 0.1 divided by 0.1. These divide out, and I get 1 divided by 0.1 is equal to 10. So that works for all of those decimals that we were doing earlier, and let's go ahead and apply this to the table method. So first I have the limit as x approaches 0 from the left side, so I have all these little negative values. 1 divided by negative 1 is still equal to negative 1. 1 divided by negative 0.1 is equal to negative 10. 1 divided by negative 0.01, negative 100. 1 divided by negative 0.001 is negative 1,000. So as we approach negative infinity, we get really tiny in terms of our number. Negative 1,000 is pretty small. Let's go ahead and look as we approach from the right. So I have all these x values approaching from the right side. So if I were to take an educated guess, it looks like this one's approaching negative infinity and this side's approaching positive infinity. Let's go ahead and look at our graph and make sure. So as I'm approaching 0 from the left side, I'm going down to negative infinity. It's just going to go on forever and forever. When I'm approaching 0 from the right side, I'm going all the way up to positive infinity, going on forever and forever. So filling in these limits, I get negative infinity and I get positive infinity. So notice how these values actually change. When x was approaching infinity, they both had a value of 0. But now, since we're approaching 0 from opposite sides, we approach opposite infinities. Let's go ahead and look at this application 2. So we have the limit as x approaches 2 from the left side of 1 over x minus 2. This is really similar, and I'm going to draw my squiggles, to the limit as x approaches 0 from the left side of 1 over x. Because if I were to plug in 2 right here, I'd get 2 minus 2, which is equal to 0. But we're approaching 2 from the left side, which means we're going to plug in values like this. And all of these values, when you subtract 2, give you a negative value. And so that's why it behaves similar to this, which we know goes to negative infinity. Now, if we were to approach 2 from the other side, we're going to plug in values like this. And we're going to get smaller and smaller positive numbers, which is why it behaves like this limit, which we know goes to positive infinity. So this is a small application we're going to look at more in the future, so make sure to stay tuned for that. But I have one more note before we go. What happens if we were to raise 1 over x to different powers? How does that affect the limits at 0? So if we square a number, we get positive. We always have positive values, which is going to change our left limit to equal infinity, and our right limit still equals infinity. But when we raise it to the power of 3, when we raise a negative value to the power of 3, it's still a negative value. So we get negative infinity and positive infinity. So be careful to look at how exponents affect our limit. And we'll go ahead and dive into more applications of this in the next video. Thank you so much for watching. That's all I have for us today. If you enjoyed this video, please leave a like and comment other videos you'd like to see or problems that you'd like to see done. Thanks for watching.